All right, welcome to This Explainer. Today, we're taking a spatial journey across humanity itself to unpack what we call the crowded planet paradox. If you're at all fascinated by how our world actually works and where exactly everyone on Earth is hiding, well, you're in the right place. We're going to bypass all the noise today and look directly at the geographic data that dictates human survival, settlement, and ultimately our future. Okay, so let's just dive right into this. Our beautiful blue and green planet feels absolutely massive, right? We've got these sprawling continents, endless horizons, and vast open plains. But human settlement? It's not spread out evenly like peanut butter on toast. It is incredibly, almost shockingly, concentrated. Here is the crucial reality. 80% of humanity is crammed onto just 20% of the Earth's landmass. Think about that for a second. The vast majority of our entire global family is squeezing into a tiny fraction of the available real estate, leaving the rest of the planet virtually empty. And this isn't some random accident. It's a direct result of geography. To truly grasp this paradox, we need to understand the underlying geography. So, Section 1, Population Distribution and Introduction. When we talk about population distribution, we're really just talking about the spatial arrangement of people across a region. But it's not just about drawing random dots on a map, right? This phenomenon is deeply, deeply reliant on geography. Earth provides the natural resources for our livelihoods, the literal materials for our housing, and the very foundation for our survival. Basically, where the geography is favorable, humanity thrives. Where it's harsh, we're just absent. So what actually makes a specific geography favorable? Moving on to Section 2, Factors Affecting Distribution. It begs a pretty simple but profound question. Why do people live exactly where they do? Why are you living exactly where you are right now? Well, it essentially boils down to a mix of two major categories of factors. First off, nature sets the baseline rules through physical factors. We naturally seek out flat topography to build our homes and infrastructure. We absolutely rely on steady sources of fresh water. We gravitate towards moderate climates because, let's face it, extreme heat or freezing cold actively repel mass settlement. And finally, soil fertility. Even in our hyper-modern, tech-driven age, if the land beneath our feet can't grow food, it simply cannot sustain a dense population. But, nature is really only half the story. Human factors are the magnets that pull us together in massive numbers. Industrial development creates these booming job markets that spur huge migration. We also crave community homogeneity. We naturally cluster with those who share our cultures and our traditions. And finally, the complex division of labor between agriculture, manufacturing, and services. It requires us to live closely interconnected lives. Knowing these physical and human drivers, let's zoom out a bit. Section 3, World Population Concentration. This reveals the ultimate geographical divide. A staggering 90% of the world's population lives in the Northern Hemisphere. That leaves a mere 10% in the Southern Hemisphere. Why? Well, because the Northern Hemisphere simply contains more hospitable landmass, much better physical climates, and the historical hubs of industrial development. The geographic conditions for human settlement are just vastly superior up north. When you look at the global picture, the reality is stark. Massive, dense clusters of human concentration stand in sharp contrast to vast, completely empty spaces in places like northern Canada, the Sahara, the Amazon, and central Australia. Humanity is basically clinging to the edges of continents, the river valleys, and the temperate zones. The sheer density of these specific clusters is honestly astounding. 70% of the entire global population lives in just three main regions: East Asia, Europe, and Northeastern America. And the numbers could even crazier. Southeast Asia alone holds about 50% of the world's population on just 10% of the Earth's land. Europe? It holds 11% of the population crammed onto less than 5% of the global landmass. Zooming in on East Asia, we see the absolute most extreme examples of this crowding. This region is home to massive agrarian societies where the climate and soil fertility heavily favor farming, which in turn supports immense populations. We're talking about India holding 16.4% of the world's population, China with 18%, and countries like Indonesia at 3.44%. Looking at the raw numbers, China and India are the undisputed heavyweights here, each crossing the billion mark and vastly outpacing the United States, Indonesia, and Brazil. The sheer volume of human life concentrated in Asian nations is pretty much the defining demographic reality of our planet. But let's balance the scales a bit. Shifting our focus westward, consider Europe. Western Europe is another fiercely concentrated zone. However, unlike the heavily agrarian drivers we see in parts of Asia, Europe's density is deeply tied to historical industrial development, incredible infrastructure, and a highly favorable temperate climate that has supported sustained population growth over centuries. When you combine the clusters of Asia, Europe, and North America, you discover a true geographical sweet spot. A staggering 75% of the global population lives between the Tropic of Cancer and 70 degrees north latitude. That specific latitudinal band offers the perfect mix of climate, seasons, and agricultural viability for human beings to just thrive. Now, geographers actually have specific terminology for categorizing these regions. Section 4, livable spaces, also known as the ecumene. It's a fundamental binary in geographic science. On one hand, we have the ecumene. These are the livable spaces where physical and human factors align perfectly for settlement. Contrasting that is the non-ecumene, hostile, unlivable spaces where the climate is too severe, the terrain is too rugged, or resources are just too scarce for permanent large-scale communities. But habitability really exists on a spectrum. You've got the intensive ecumene, think highly urbanized, bustling industrial cities. Then it steps down to the extensive ecumene for widespread agriculture, into exploitation zones for things like mining, sporadic spaces for scattered activities, all the way down to the non-ecumene, which is just empty space. Our lives are entirely dictated by which of these zones we happen to be born into. To truly understand the pressure on those intensive zones, we really have to look at the numbers. Section 5, the math of population density. While population distribution tells us where people are, population density tells us exactly how crowded those places actually are. It is a measurement of the number of people in a specific area, calculated as an average number of persons per square kilometer. Basically, it's the metric that measures the squeeze. And when we break this down by continent, the contrast is staggering. Asia leads the pack with a massive 108 persons per square kilometer, and Europe is right behind at 101. But then, there is a massive drop-off. South America and Africa sit in the low 20s, North America is at 14, and Oceania is vast and virtually empty, with an average of just 3 people per square kilometer. Summarizing this whole global divide, we are essentially left with a planet of extremes. On one side, densely populated powerhouses like Southeast Asia and Western Europe, bursting with activity, industry, and human capital. And on the other side, sparsely populated, resource-rich, but physically challenging frontiers in places like South America, Africa, and Australia. Which leaves us with a totally critical thought to end on today. As our global numbers continue to steadily rise, but our favorable geography remains perfectly fixed, how will these extreme spatial paradoxes shape the future of our crowded planet? Will new technology allow us to finally conquer the non-Eucumene? Or will those dense clusters just keep getting denser? Thanks for joining me on this explainer today. I really hope this spatial journey has shifted how you view the map of our world. Keep questioning and keep learning.